In firefighting and public safety, reliability is key. For over 20 years, the Fire Store has equipped first responders with trusted gear featuring brands like MSA Carnes for helmets and Seek for thermal imaging cameras. Stay prepared. Visit thefirestore.com today. The Fire Store, your trusted safety partner.
Hi, Chris Mc Loone here with Fire Apparatus and Emergency Equipment. Welcome to this episode of our Moving Water podcast. With me when we talk about water, as always, is Bill Adkins and Andy Soccodato. We're going to be talking today about different line selection. We're going to be focusing on supply line. We'll talk a bit about it from the hydrant side, and we're also going to talk a bit about it from the more rural side, where we're talking about tankers and dump tanks, etc. But Andy, Bill, thank you very much for joining me again. It's been a little while since we were able to get together here and talk flows. Also, these guys are going to be teaching at FDIC in just a couple of weeks now, I guess. Boy, it's getting very close, a little bit uncomfortably close for me. As we get everything together on our end. But again, thank you both for joining me today. Bill, I'm going to throw this first one out to you, and like I said, we're going to be focusing a lot on supply lines today. I guess just to get us started, talk about some of the different options. Now, I think most people probably know, because they're sitting there and they're going, well, I have 3-inch, I have 4-inch, I have 5-inch. If you really want to get crazy on the industrial side, some people get 6-inch. I've seen 12-inch deployed during different drills, but there are certain reasons you want to pick some of those lines. So talk about the different options for these lines, and then talk about a little bit of the criteria that we're using to make the selection when we get to the scene.
Sure, Chris, and thanks for having me again. As far as options goes, one thing I usually teach is if you have 5-inch, use 5-inch on every fire, even for the small fires, because the small fires may turn into something completely different later on in the scene. If you're not being able to get to the seat of the fire and it keeps growing, so we don't want to have to go from 3-inch to adding to 4-inch or even 5-inch. I just go with whatever your supply lines are. Use the largest that you have on every fire. However, a lot of people have a lot of opinions against that. And every fire doesn't need 5-inch supply, So what they will use is, if it's a smaller fire, they'll start with that 2.5 or 3-inch, and then if they do need to go on up, then they can move to 5. Like I say, I don't usually teach that way, just because when the scene is going on and on, we don't have time. The operators may not have the time to add that extra supply line. So one of the things I teach is go with whatever the largest you have. But as far as the options, we do have 3-inch, 4-inch, and 5 on all of our apparatus.
Now, one of the things you just mentioned, and Andy, I'll throw it over to you to add to what Bill said, but also I want to make sure, in a booster backup situation, well, I guess, Bill, first I'll ask you, in a booster backup situation, would your first choice be the 5-inch again, or would you step down to the 3-inch?
The 3-inch. That's where, if I'm doing a booster backup, yeah.
All right. So we're only talking about, because you could easily go, 5 from truck to truck.
Right.
But we're talking here. We're going to focus on supplying from a source, to the scene. So Andy, what have you got to add to that?
Yeah, absolutely. So, thanks again for having me again. And, it's an honor to be back. But really, like you hit on, application matters. Okay. And for booster backup situations, I personally am perfectly fine with the 2.5 or 3-inch going from rig to rig. And what's important about understanding why that is okay is because most of your rigs, depending on how they're plumbed and what you spec, your tank to pump valve is only going to be capable of flowing about 500 gallons a minute. That's what the 1900 standard says. So all you're going to be able to give in that booster backup scenario is about 500 gallons a minute. And 2.5 or 3-inch hose going from one rig to another rig, that is perfectly sufficient for that application. But what is really important for folks to understand and remember is that when we're going from the source to our fire scene, right, especially if we're using a fire hydrant, obviously if we're using a static source, we know that we need to put a pumper there, right? We need a pumper to pump that water to the fire scene. But where I feel there's a little bit of a disconnect and where this argument gets a little muddy, so to speak, is when we're dealing with fire hydrants, right? A lot of people are under the impression that the fire hydrant is capable of delivering all the volume it has from the hydrant to the fire scene over a long distance. And that just simply isn't the case. Now, some of us are lucky and we have hydrants that have really, really good pressures at high flows. But for most of America, that's not the case. For the majority of the hydrants that we're dealing with, folks need to remember that fire hydrants are only capable of delivering their capacity at 20 psi residual pressure in the main. So 20 psi is not a lot of pressure to overcome friction in a very long lay. So compound that with the choice of supply line that I use. If I'm using 3-inch between my hydrant and my fire scene, well, now my flow rate has just gotten completely crushed. So what is important for people to understand is a fire hydrant gives you volume. It doesn't give you pressure, right? It doesn't create pressure. It gives you the volume. We have pumping apparatus that we're spending anywhere between, $500,000 and $1 million today on that are designed to overcome pressure. So designed to overcome friction by building pressure. So regardless of the supply line I choose, if I want to get the capacity of my source, I need to put a pumper on that hydrant to actually pump the water that the hydrant's capable of giving me down to the other end. Now, depending on the supply line that is laid, whether it be 4-inch or 5-inch or even 3-inch, right, that is going to dictate what pressures I need to be at and or how many lines I need to lay, right? And that comes into a lot of people get into the argument, well, should I be in 5-inch or 4-inch? That's it's a hard question to answer. There's a lot of variables that go into that, right? What are you expecting to flow? What are your relay distances? What are the distances between your hydrants and your fire scene? What are the pressures you're dealing with, right? What kind of plumbing does your truck have? Can it support 5-inch flows? Can it not support 5-inch flows, right? Do you need 5-inch flows? I know a lot of experts in the industry, they will say, 5-inch hose is too much for residential fires, but not enough for industrial fires, right? So it's kind of that weird sweet spot where it's giving you a little more water than you need for a residence fire. And that's probably why some people are adverse to putting it on the ground. However, it's not giving you quite enough for what I need on these larger fires where I'm probably going to have to lay dual 5s anyway. So what's important to understand is what are my flow requirements? And depending on the hose that I'm in, that is going to dictate how many supply lines I need to lay. What's really important to understand in my mind is hydraulic equivalencies. How many of this size line equal this, right? If a 5-inch can flow this much water, how many smaller lines do I need to use to equal the same volume?
So speaking of that type of thing, in a situation where a truck is connected to the hydrant and can supply you, but maybe you're pretty close by, maybe just however the circumstances are, just that, it didn't take much. In the math in your head, you might say, well, 2 3-inches going into that truck will be the equivalent of a 5-inch because 3 + 3 is 6, and we're trying to equal a 5-inch. How does that work hydraulically And is that actually the case? And I mean, and I sit here and I go, well, this might to some be a very duh question, but when, the middle of the night, maybe not as experienced a pump operator or something, they might be thinking, that they're doing perfect. I know that for us, for example, I know that, before we had trucks that had, 5-inch discharges, we had a Y or it was a Y, that we connected to a 5-inch that's going to the scene. And then we ran 2-3 inches into it to try to equal, we were doing the best we could. Those 3 inches were the biggest discharges we had on the truck. So hydraulically, I guess, is that the case? And what do people need to be thinking about? I'm talking truck to truck here, maybe not, laying 2-3 inches up the street.
Sure. Yeah. So I think what you bring up is a common misconception in the fire service, right? I look at, okay, I have a 3-inch diameter hose. So if I use 2 of those, that's got to equal 6 inches in diameter. We're looking and comparing things the wrong way, right? Diameters, right? When I measure diameter, 3-inch and 3-inch equals 6. That's not the case. When we're talking about hydraulics, we have to actually look at the area opening, right? And in the American Fire Service, we don't distinguish our hose by area. We do it by external or internal diameter, right? So when I'm looking hydraulically, 2 3-inch lines actually do not equal a 6-inch or even a 5-inch. Hydraulically, 2 3-inch lines are only equivalent to a single 4-inch supply line, right? And that's what's really important. And a lot of people are like, well, that doesn't make sense. 3 plus 3 is 6. We're looking at the square inches in that hole, right? How many square inches are in that 3-inch? If I have 2 of them, their combined area would be the same as 1 4-inch hole. That's where we need to be thinking. So that's why a lot of people, and I know we're going to get into the rural environment, a lot of people are like, hey, we're running 3-inch in our supply bed. We're thinking about making the switch to large diameter hose. Should we make the switch? And in the rural community, you really have to ask yourself, right, do I want to make that switch from 3-inch to 4-inch? Because hydraulically speaking, if I drop 2 3-inch lines, I have 4-inch, right? I can move the same volume of water with the same amount of friction loss as a single 5-inch. And just to kind of put it in perspective, if anybody's following along trying to do the math, right? So let's say I'm trying to flow 1,000 gallons a minute through my 4-inch hose, right? 1,000 gallons a minute through 4-inch hose has roughly 20 pounds per 100 foot of friction loss, okay? So if I take a 3-inch and a 3-inch and put them side by side, and I'm trying to deliver the same 1,000 gallons a minute to the other end, in order to accomplish that, hydraulically, I'm going to be splitting the flow. One line's going to be flowing 500. The other line is going to be flowing 500 for a combined total of 1,000. Now, when we do the math, since the 2 lines are the same diameter, we're going to assume for our scenario they're the same length, blah, 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 blah. I do the math for one, and then the pump pressure is going to be the same in the other. So when I do the friction loss in 3-inch hose at 500 gallons a minute, it's 20 pounds per 100 foot. So I deliver the same 1,000 gallons a minute at the same exact pump pressure as I would if I were feeding that single 4-inch hose. That's really, really important to understand. Now, a lot of people are like, okay, well, I'm not in 4-inch, so why are you doing a 4-inch example? I'm in 5-inch. Well, hydraulically speaking, 3 3-inch lines equal a single 5-inch supply line. That's what we want to remember. 3 3s equal a 5, okay? So that means if I want the same flow as a 5-inch supply line, I got to put even more hose on the ground. Now, what is really important is, and again, I'm not trying to start a hot debate, but what people should really consider is, I love 2.5-inch hose. 2.5-inch hose has its place in the American Fire Service. In my opinion, its place is on the discharge side of the pump, going to a nozzle or a handline nozzle, or maybe a master stream, portable master stream, blitz fire, something like that. 2.5 is not a good supply line for today's modern flows and modern fuel loads. And it's because when I look hydraulically speaking, I need 3 2.5-inch lines to deliver the same volume as 1 4-inch supply line. So I got to lay 3 for a 4. If I'm trying to compare it to 5-inch hose, I need to put 5 2.5-inch lines on the ground to equal 1 5-inch supply line, right? So I would personally much rather lay the single 5 and pick up the single 5 than have to pick up 5 times the amount of hose for the same flow at the same pressures.
Now, Bill, when we're talking about hydrant pressures and hydrant flows, a limiting factor can be the size line we choose to go with from that hydrant. But also there's 3 caps on that hydrant. So when we're talking about if you have a hydrant that's on a big main, what are some tips to getting the maximum flow out of that hydrant? I mean, we've seen simply, putting a pumper on the hydrant with like a 4-way valve or something on the front of it. We've seen 6-inch hard sleeve coming off of that steamer by itself, going straight into the pump, no valve. We've also seen examples where you've got lines coming off all 3 of those from all 3 of the discharges on the hydrant. So talk about some tips for getting the maximum flow out of that hydrant, to the seam.
Right. Okay, and I'll keep this answer simple because I know Andy's been chopping at the bit to answer this one. I'm sure he's known for this. And I've learned this from Andy in one of his classes. And that's we try to use all 3 discharges if we're trying to flow a lot of water. We at Loveland Sims, we have mains that are 20 plus inches. And, we're obviously not going to get all that 20 inches out of even all discharges. But if we're going to an industrial style fire, we tend to try to usually the second hydrant that we start, our second water source, we're going to hit all 3 discharges to help supply that extra water. Usually that first new company, they've got enough going on in the first place to try to hit all 3 discharges on that first hydrant. But to get the maximum amount of flow out of your hydrants, we will use 5-inch on all 3 discharges. We have a 2.5 to Storts fitting, and also the 4.5 to Storts as well, so that we can have 3 5-inch sections of hose. And mainly that's for the friction loss, like Andy mentioned earlier. Lot less friction loss on 5-inch compared to 2.5, 3-inch, and 4. So that's what we use to maximize our max flow out of those hydrants. On the flip side, on the Royal side, we have hydrants that have 2.5-inch mains at sometimes. So it's not going to do you any good to even use a 5-inch discharge off of it. We still use 5-inch for the friction loss aspect of it, but we're not going to try and heavy hit a hydrant with that. What Andy's going to talk about, the heavy hitting hydrants hitting what we call when we're trying to flow out of all discharges. So it's something we don't do in the Royal area, but in the city we do.
You ready, Andy, to take it away?
I'm ready. So what Bill hit on right there is spot on, right? What is important to first recognize is the water needs to be in the ground in order to make a double or triple or a heavy hydrant hookup useful. If you're dealing with a garbage hydrant that has garbage flows, you can hook it with 20-inch hose and it's not going to create water, right? Heavy hydrant hookups, using multiple ports, all of that is only beneficial when the water is in the ground, when it's a high volume hydrant, okay? When it's a high volume hydrant. So what we're talking about here is our green tops, our blue tops, things that can flow more than 1,500 gallons a minute, stuff like that. Because what's important to understand, friction is a real pain in the rear end, right? Friction loss increases way faster than an increase in flow rate. Okay. And if we remember from our hydraulics equations and all that good stuff, friction increases the most when I increase the flow. Q, or the flow rate, is the only variable in that friction loss formula that gets squared, right? And that means it gets multiplied by itself, meaning that if I double the flow rate, I quadruple the friction loss. So if I have a really strong fire hydrant that can give me 2,000 gallons a minute, that's great. The friction in that supply line is going to be really high when I try and flow 2,000 GPM. So, Bill hit on the importance of multiple intake connections, using all three ports on the hydrant, all that. What I cannot stress more is the fact that people should recognize, if I have a high volume main, high volume hydrant, the first step is assigning a pumper to pump that hydrant, right? I need to put an engine on that hydrant, okay? Because if I don't, the hydrant is not going to be able to overcome the friction loss. And a lot of people will ask, okay, or some people will send pictures like, hey, we triple tapped this hydrant, and they laid 3 5-inch supply lines from the hydrant 500 foot to our fire scene. That's still not helping, because there's still friction in each of those lines that the hydrant cannot overcome. But when I put a pumper on that hydrant, that thing has a diesel motor, has a pump. It's designed to overcome whatever friction loss is in that supply line. And it's the equivalent of taking the hydrant out of the ground and moving it over to my fire scene, right? I personally, and this I have to be careful how I say this, because I don't want people to take it the wrong way. I like large diameter hose. Large diameter hose is great and allows us to move big water and this, that, and the other. But unfortunately, what it has done in some communities is it has gotten fire departments out of the mindset of putting an engine on the hydrant, because their thought process is, we can lay that 5-inch, hook it directly to the hydrant, lay from the hydrant, and then just use hydrant pressure to deliver our fire flows. And that is fine for low flow fires, right? The issue becomes when I double or triple the flow rate at my fire scene, because now my friction loss is quadrupling if I'm doubling the flow, right? So now we are going to see a dramatic drop on our intake pressure down at the fire scene. And a lot of times what people will say is, well, I'm out of water. We ran out of water. The question is, did you really run out of water, or did friction loss in your supply line, whether it be 4-inch, 5-inch, whatever, did that hurt you? Was there still pressure at the hydrant? It just couldn't overcome the resistance in the hose to deliver the volume. So putting an engine on that hydrant is critical. So in my mind, to simplify it, that happens one of 3 ways. There are one of 3 ways that happens, right? Option 1 is I tie an engine into the hydrant from the beginning. Before water goes to the fire scene, I put an engine on that hydrant, they're heavy hooking, and they're sending water. For larger urban areas, that might be a realistic option, because we have a bunch of companies come in, this, that, and the other. For suburban or even rural communities, that might not be an option, right? Your second or third due engine could be minutes and minutes and minutes behind, and we need water before that. So that's where option 2 comes into play. Option 2 is I can use a 4-way valve, like we've talked about on previous shows, right? Put the 4-way valve in there, and if I need somebody to boost the pressure, they can do it. Option 3 is I don't have a 4-way valve and I'm not waiting, so I'm going to hook the supply line directly to the hydrant and I'm going to use hydrant pressure. Okay, that's fine. For a lot of us, that's what we got to do. But understanding that if the flow increases, right, I might have the water at the hydrant, it just can't overcome the resistance. So now what I have to do is tie an engine into that hydrant, all right? Now, without a 4-way valve, that's going to require us to shut down the hydrant, break the connection, tie an engine in, and then reestablish the flow, okay, which takes time. And that's the major disadvantage of doing it that way. Now, something that I'm working on, and an article that I'm currently working on, is a process that the Columbus, Ohio Fire Department has mastered, and they call it the Columbus changeover, because that's exactly how they do business. They do forward lays from the hydrant to the fire scene, connect the supply line directly to the hydrant, and if they need more water, they will assign a later arriving engine to come to the hydrant, break those connections, hook up real quick, and then send water down. They have gotten to the point where they're so proficient at doing that the interruption in water is about 30 seconds on average. They're able to make all of that and make that transition in about 30 seconds. So if it's an option, but it's an option that you have to train on. And what separates the Columbus, Ohio Fire Department from other places is when they assign an engine to do that procedure, it is an engine company. It's not an engine operator. So they have 3 to 4 people working on that operation rather than just saying, hey, engine 9, go do the changeover. And that one operator's having to do a bunch of different things.
Talk about some internal piping. Bill, take me through. I mean, Andy talked a little bit about that tank to pump valve earlier. Just talk about, is there anything we can do behind the pump panel? If you're setting your truck up to move water, is there anything we can do behind the pump panel to ensure that we're getting the max that we can out of whatever source we've hooked up to? I don't know if it's just the diameter of the piping inside, just spec it with fewer bends. Like what can we do on the inside, like behind that pump panel, to ensure we're getting the max flows?
Absolutely. One of the things is you got to know what operation that you're going to use. And I'm talking more royal stuff than working with a hydrant. But we use the nurse tanker system at Fayetteville here. And because we know we use the nurse tanker system, when we spec out a truck, we make sure we add an extra tank to pump. Because on both of our tankers have both 2 tank to pumps. One has 2 4-inches, one has 2 3-inch. That way we can know we can get the max flow out of our tank water for that initial big knockdown. Also, as far as moving water, we need to make sure, like what you mentioned there, less bends in your pump panel, behind that pump panel. If you have a discharge coming off a pump and it has 2 bends on it between it before it gets out to the outside of that panel, then you got a lot more friction loss there. So we try to, I know a lot of people like to spec out their truck with nice, neat looking pump panels. But if you open up the back of that pump panel, it's a disaster looking back there because it's all the bends that the apparatus manufacturer had to do to make that look good on the outside. My opinion, I don't care what the outside of the pump panel looks like. I want it to be nice, smooth pipe plumbing behind that pump panel so that we can get that max flow without having to worry about their friction loss starting at the truck itself. We already know we have to deal with friction loss from the truck to the scene, but we need to also, you got to count that friction loss that's in behind that panel. So set your apparatus up, your pump panel up for success on your operation, your particular operation.
Andy, I want you to add to that, of course, but also, this is my fault for the way I kind of phrased the question in terms of designing your pump panels and stuff. We can get big flows out of rigs that are 15, 20 years old. So not only do I want you to add on to what Bill said, but also because it's usually your pictures are the ones that I call out that's an older rig that's still moving some water. So besides adding to what Bill said about, if you're, kind of putting something together now to move water, also mention, that there are things that departments can do to overcome any of the shortcomings they may experience on behind the pump panel on trucks that they already have.
Yeah, absolutely. So the first thing is to understand that plumbing diameter and specs matter. How you write your specs and what the internal plumbing is really does matter. And the next thing that folks should pay attention to as much as I know a lot of people, don't love to hear the word, the acronym NFPA, but NFPA 1900 actually, or 1901, the old standard, has a lot of information that can tell you what you should be able to expect. And in that standard, it actually specifies what the minimum flows have to be based on discharge plumbing size. Okay, depending on the size of the discharge, it has to be able to flow a certain volume. So 2.5-inch discharges have to be able to flow 250 gallons a minute with a minimal amount of friction within the pump. 3-inch discharges are 375, 4-inch discharges are 625, 5-inch discharges are 1,000, and 6-inch discharges are 1,500. So a lot of people will look at their rig and say, well, I have a large diameter discharge, so I should be able to flow the capacity of the pump because it's a large diameter discharge. But then you go and you look at, I can connect a 5-inch to it, but what's the back of it? What is the actual plumbing? And depending on your truck manufacturer and when it was built, that plumbing may be 3-inch, maybe 4-inch, right? So what that's important for folks to understand is, especially if it's 3-inch, am I going to expect 2,000 gallons a minute out of it? I might be able to get 2,000 GPM through the plumbing, but the amount of friction loss that is in that plumbing assembly is going to be extremely high, and the motor is going to be screaming trying to overcome the friction just within the pump to get it from the discharge to the outlet side. So speccing it correctly and knowing what your discharges are is really important. But here, and this is something that I talk about in my book, and making sure that you know what discharges are doing and how to plumb things and what the realistic flow for a discharge really is. A 3-inch discharge that very well may be your large diameter discharge. The standard says it has to be able to flow at least 375. Can I flow more than that? Yeah. Am I going to expect more than 1,000? Probably not, right? Because the amount of friction within the pump is going to be so great that it is, not worth, the juice isn't worth the squeeze, so to speak. So a lot of people hearing this might say, all right, well, if I want to move big water, I'm going to plumb and I'm going to spec 6-inch large diameter discharges on my rig. You can absolutely do that. That's what you would find on an industrial pumper, and you're going to pay for that. That is really, really, really expensive. Not to mention, because of the larger area and diameter of that plumbing, that is going to change the whole vehicle dimensions of your truck. Right, your wheelbase may be super wide now just to accommodate that one discharge. So for me, what I tell people, if I'm building a municipal pumper that is set up to flow water, big water, I want at least one 4-inch large diameter discharge. The plumbing will be 4-inch with, if I'm using 4-inch hose, 4-inch Storts, or 5-inch Storts, right? Either way. All right, at least one of those. Or what I can do if I'm really serious about moving a lot of water, I'll spec 2 of those, 2 4-inch large diameter discharges, because now, in my experience, a single 4-inch LDH discharge plumbed, you can easily expect 1,000 gallons a minute out of that discharge with a minimal amount of friction within the pump. So if I just hook 2 4-inch lines to each of those discharges, I'm throwing 2,000 gallons a minute. And I'm not giving the pumper or the motor an aneurysm trying to do it, right? So here's the other issue that I run into a lot, and I'm sure Bill does too. A lot of people probably think, well, I have a 2,000 gallon per minute pump, right? And I have a large diameter discharge. So I should be able to flow 2,000 gallons a minute out of my large diameter discharge. And it doesn't work like that, right? What people have to understand is, that pump rating is based on 3 things. There's 3 variables that go into what a pump is rated at. The first is the size of the impeller. What impeller am I dealing with, right? Am I dealing with a big impeller that has a large eye that can receive the water? Or am I dealing with a small impeller? The second is the number of discharges. So when I spec a 2,000 gallon per minute pumper, right, that 2,000 GPM pumper is going to have more discharges on it than a 1,500 gallon per minute pumper, right? It's going to have at least two more 2.5-inch discharges, or it might have one more, 4-inch discharge, whatever. The total combined number of discharges has to equal the pump's capacity. And then the third variable is the motor, the horsepower of the motor. How big of a power plant do I have to actually spin that impeller? Why is this important? Well, when I'm pump testing a rig, what people need to understand, obviously that's at a draft, but that pump test occurs through multiple discharges. We are hooking hoses to multiple discharges on that rig to get that pump's rated capacity. We're not just hooking it to that large diameter discharge and saying, all right, jam the pump's rated capacity through this one hole, right? No, that's not how pumps are rated. So to answer your question, Chris, about how do I make a older rig flow large water? It's simple. I just use lots of discharges on the rig. A lot of these older rigs, they have multiple 2.5-inch discharges, or maybe it's a 1,500 gallon per minute pump with no large diameter discharge. That means it's going to have a lot of 2.5-inch discharges. So here's what I do. I just take 2.5 or 3-inch, little short sections, 50 foot long, have them come off those discharges, and then I put them into a Siamese to feed a 4 or a 5-inch line, right? So now I'm reducing the friction within the pump. I'm getting the water in. I'm able to easily get it out, and then it reconverges in that 5-inch that sends, or 4-inch, and sends it on down the line. Okay, that's how I can make an old rig perform just like a rig that has one 4-inch or two 4-inch large diameter discharges.
Well, I think that's an important point that, especially when we're talking about, departments that may not have the budget to upgrade their rigs as often as other departments are, that doesn't mean you're limited in the flows that you can achieve through those older rigs. And I mean, gosh, but you think about it now, I mean, gosh, rigs that are 20 years old now probably are in pretty decent shape. The ones I'm thinking of, I shouldn't say decent shape, are probably spec'd out with a lot of those larger diameter discharges and such, and the larger pumps. The ones that I'm typically thinking about now are probably in that 30 to 40 year range that we're talking about.
And those rigs, that's where, like, if I'm investing in stuff, or if I have a rig that's 30, 40 years old and doesn't have large diameter discharge plumbing, right? That's where I'm going to be investing. I may be carrying a couple extra Siamese appliances on the rig, right? That's a lot cheaper, and I can throw those on. So now I know, hey, if I need to pump a LDH supply line, right? Somebody can lay the supply line from me. I'll hook my Siamese in, and I'll put 2 or 3 or whatever the appliance is capable of receiving, and I'll pump your 5-inch all day long. It's not going to look the same as me taking a brand new rig and hooking it right to my large diameter discharge, but the result will be the same because hydraulically it's the same.
Now, on the rural side, originally when as you guys were talking, I was thinking about this, my thoughts were going to, on the rural side, is there a general GPM that we're looking to flow? But that's not really the right question. But I do think, it's probably one of those, well, Chris, it depends answers, that we get. And it's, the truth. But is there a limit, I guess, to what on the rural side when we're laying line, or we're doing a nurse tanker evolution? Is there a limit to the GPM that we can realistically expect to flow in those situations, or does it really just depend on, if you're drafting whatever the truck is that's sitting there at the draft site and its capabilities of moving the water, as well as if you need to do a relay? I'm kind of jumping around here, but Bill, what is there on the rural side? Is there a limit that people should think about, or does it really just? I mean, it's going to depend, I guess, on the GPM you want at the scene. So if it's one of those big industrial complexes, you'll have that. If it's a house fire, you'll have what you need there. But But I guess, are there limitations because I'm a municipal guy, so I don't know the drafting side of all this. Are there limitations on that side that people need to be aware of?
Yeah,
and I guess, how does that impact your supply line selection?
right. Far as our supply line selection, it doesn't impact it because, like I mentioned earlier, we always just go with the 5-inch on everything. But we have to remember, like Andy mentioned earlier, your tank. If you're going to use your tank water, your booster water initially, you can only flow whatever it's set up to do. And most of them are 2.5 or 3-inch tank to pump valves. And but to answer that question a little more clearly, one thing we got to do is we got to calculate how much fire flow we need for that particular incident. And that's, we use the formula of width times length divided by 3. And that gives us our fire flow. And in a rural setting, most of the time, it's around 500 gallons a minute. But we have some buildings close by, not necessarily in our jurisdiction, that are several hundred feet by several hundred feet. So that number drastically increases. So, speaking for the most part, it's around the 500 gallons a minute in the rural community, but there are some buildings that require much, much more than that. And if I'm speccing out a new apparatus, I want that apparatus to match what our jurisdiction is required.
Andy, how about you? Anything on your end?
Yeah, I agree 100% with Bill, right? It really, as far as the limitations, as far as what I'm going to be able to deliver, it's going to be based on the pump capacity of the drafting engine and everything like that. How I set up my drafting operation. Am I doing a twin tube? Am I doing a triple tube? What intake valves do I have? But the big thing when it comes to supply line selection is, I love large diameter hose for municipal operations. And I know I go to a lot of rural communities that will say, well, we're thinking about going to 4 or 5-inch hose or anything like that. And something that I like to caution rural communities and rural fire departments about large diameter hose is, if I lay that hose up a driveway, let's say I have, several hundred foot up the driveway, and I'm going to have either a tanker that's going to be nursing me, or when I'm setting up my dump site and pumping up that supply line, right? It takes water to fill that hose, right? There are no free lunches. So when I'm dealing with large diameter hose, depending on the size of the hose, it's going to dictate how much water is just lost filling the hose. 4-inch hose, it's 65 gallons per 100 foot. 5-inch hose, it's 100 gallons per 100 foot. So depending on how long that lay is, that is going to dramatically kill the available water to fight the fire initially, just because we're filling the line. This is where, personally, for some rural communities, I am not opposed to the idea of using 3-inch supply line in a split bed configuration, where I will lay dual 3-inch lines up my driveway, so I have the ability to flow what a 4-inch could if I charge both of them, but I don't need to charge both right from the beginning. I can charge one 3-inch line and only use 37 gallons per 100 foot to actually fill the supply line and get water going to my fire while I build out my dump site, or while whatever happens. And if we need to go to a larger flow, okay, no problem. We'll charge the second 3-inch. And now I got 2 3-inch lines going up the driveway. Hydraulically, I can move the same amount of water as if I had that 4-inch hose. The pain in the butt about it is now I have twice the hose to pick up, but, right, depending on your fire, you may not even have to charge the second 3-inch, right? You drop them both, but you don't necessarily have to charge both. And to me, that's a better option for rural communities that are, trying to deal with water conservation and using the water for the firefight, not using it to fill hose, right? If you're a rural organization that does 50-50, you do some drafting, you do some hydrant work, well, then maybe having a split bed of 3 inches is the best option, because it's not going to be as great for your hydrant side. It may hurt you on your hydrant side. So that in instance, I might be using LDH regardless. But for our rural communities where they don't have any hydrants and they don't know what hydrants are, right, I like split beds of 3-inch medium diameter hose.
Now, a lot of things that we've talked about today have been, the trucks that could actually be the limiting factors in this, whether it's the plumbing coming out, whether it's, the size of their pumps. And I did want to touch on that for just a second, because, and I'm going back, 10 or 15 years ago, a lot of times, the 3,000 gallon tankers a lot of them were simply water movers. They were just water haulers. They were just taking one to another. Then, you had those that were getting some pumps installed on them, but those pumps were relatively small. Now, the pumper tankers that we talk about a lot, those pumper tankers that are built on commercial chassis, a lot of times they'll have the bigger pump on them because they might be, being used as initial attack vehicles. So they've got cross lays and, all that neat stuff. But Bill, for a tanker that's not a pumper tanker, and we could talk about your own tankers, are what you're seeing still those larger capacity tankers? Are they still coming with the smaller pumps, say 500 to 1,000 gallons a minute, or are they coming now with pumps that are 1,500 on up so that they can really move some water?
Yeah, I'm fortunate enough in our area that most of the tankers in our surrounding area have the larger pumps. Everything's 1,000 or more. We used to have 15, 20 years ago, a lot of the tankers would either not have a pump at all, or they'd have what they call the trash pump, 250 gallon, 500 gallons at the most. But like I say, fortunately for myself in this area here, it is everything's 1,000 or more. Most of them are 1,500 or even more. We've got a couple 2,000 gallon tankers, but with that, it all depends on your budget, because a lot of departments can't afford that. I know there's a lot of departments in the country that could never afford to put a 1,000 or a 1,500 gallon pump on their tanker. They need to spend that money on their engines. So they won't necessarily do that. What a lot of departments around here has come to what am I trying to say here? Come to terms with is when they buy a tanker, they want it to be a pumper tanker so that they can buy one apparatus to replace two. So they will use those tankers as the first due apparatus. They're buying either a commercial cab or a extended cab on a commercial apparatus, and make that the first due. Now they're arriving with 2,500 or 3,000 gallons of water instead of one. So that's why a lot of our tankers in this area here has the larger pumps, because they use it as a pumper instead.
Andy, what are you seeing when you're out there doing your instructing? Are we talking about larger pumps now? I mean, that might still be the norm. I mean, we've got FDIC coming up. I'm anxious to see the tankers that are there to see what they have on them. But what do you, as you get around, Andy, what are you seeing?
Yeah, it depends on region. I go a lot of places where they're still dealing with the trash pumps, like Bill had said, and some rigs that are running 500 gallon per minute smaller pumps. But a trend that I really like that I have seen here lately is 1,000 gallon per minute pumps. But a lot of manufacturers and departments are deciding to, instead of getting a true midship with a transfer case pump, they're going with a PTO pump and getting 1,000 gallons a minute. And the major advantage there is they don't have a pump panel that is the size of, a traditional engine. They have much smaller, narrower pump panels like you would traditionally see on like a 500 gallon per minute pump. but they're still getting that 1,000-gallon per minute capability. So to me, I really feel like that's the sweet spot. 1,000-gallon per minute pump, PTO pump. That way I have a really short, small, compact pump house that doesn't, completely destroy my tanker's wheelbase or anything like that. And like Bill's saying, I can still use that as a pumper tanker or something like that. So that's kind of what I like. It allows it to be simple. It allows me to not only potentially be an attack piece, but it easily allows me to do the nurse tanker operations or anything like that. Shoot, if I had to, I know some counties around me, they have the potential. Their tankers go on structure fire assignments that are in hydrogen areas. So now, if I needed a relay engine or maybe an engine pumping a hydrant or something, and I had one of those tankers, I can assign it there. The pump is big enough that it can actually kind of help me in those other non-traditional water hauling movement operations where maybe I have a hydrant.
Well, I want to thank you both again for joining me today. Before I let you go, though, as always, Bill, do you have any just kind of final thoughts on line selection? Anything you'd like the audience to walk away with today? General comments?
Yeah, something Andy mentioned earlier about the smaller diameter hose with less gallons of water for those long lays. Something I wanted to add there is another thing I'm fortunate with is we don't have a lot of long lays. So that's one of the reasons that I can teach that we use 5-inch on pretty much everything, because for the most part, we're going to have everything less than a few hundred feet. Now, we do have those driveways that are 1,000 feet or plus. We may change that operation up if we have that particular incident, and the first due company officer makes that decision when they show up to change the location or change that supply line to being dual 3s instead.
Andy, final thoughts?
Yeah. So the one thing that I think is really important for the viewer to take away is, use whatever hose that works for your jurisdiction, right? Just because one place is using medium diameter hose or using large diameter hose for their supply operations doesn't necessarily mean that you have to be, right? Bill's area is different than my area, and we operate differently, and that's okay. So having hose that works for the supply operations in your area, that's what matters. That's what matters. And the viewer should really go out and evaluate all of these factors, right? What are our mutual aid partners using? What hose are they using? What are our lays? Am I going to be putting, 1,000 foot on the ground, or am I going to be putting 300 foot on the ground? Am I dealing primarily with hydrants, or am I all rural water? These are all things that need to be evaluated when I'm making the decision. Do I stay in my 3-inch? Do I upgrade to 4-inch? Should I stay in my 5-inch? Right? That's what you need to evaluate. But regardless of on the hydrant side, I cannot stress enough that I don't care if you're in New York City or in, Bedford County, Tennessee, right? It does not matter. When you're trying to do hydrant operations, if I want the capacity of what that hydrant's capable of doing, the hydrant can't overcome friction loss. It's not designed to. That's what a pumper is there for. So I have 3 options for getting that pumper on the hydrant. I can do it from the beginning, I can use a 4-way valve, or I can tie it in later. It's the only way I'm going to move that hydrant's capacity to the other end.
All right, perfect. Well, I know that Andy, I've never heard about giving an aneurysm to the pump or the engine before, but I know that the next time I'm standing in front of the pump panel, I'm going to be wondering if I'm going to be making sure that that's not what I'm doing. But thank you both again for joining me. I know it's been a while since we've been able to get together on and talk about moving water. So thank you both again for joining me today. If you have any questions for Andy or Bill and you need to get them answered, please let me know. I'm at chris.mcloone@clarionevents.com. I will get that to them. And, maybe it'll come up as another topic. If you do have if you do have a topic that we haven't hit on yet that you'd like us to tackle, let us know. Again, chris.mcloone@clarionevents.com. We'll get those topics into the pipeline. If you would like to see archived versions of these podcasts, they are all available at www.fireapparatusmagazine.com/podcasts. And if you will be at FDIC 2025, both of these gentlemen are teaching. So go to FDIC.com, look up their class, and make sure if it's information you need that you get over to it. So again, guys, my thanks to you. This has been Chris Mc Loone with Fire Apparatus and Emergency Equipment, along with Bill Adkins and Andy Soccodato. Have a good one and stay safe. Thanks again, guys.
Thank you.
In firefighting and public safety, reliability is key. For over 20 years, the Fire Store has equipped first responders with trusted gear featuring brands like MSA Carnes for helmets and Seek for thermal imaging cameras. Stay prepared. Visit thefirestore.com today. The Fire Store, your